In this section, we're going to take a look at implementing transfer learning. We're going to take a look at transfer learning with pre-built models, deep learning with VGG, then we'll move into transfer learning with VGG. And finally, we'll take a look at transfer learning with ResNet, which is another form of deep network. In this video, we'll take a look at transfer learning and pre-built models. We'll actually answer the question, what is transfer learning? And then we'll actually describe why you'd want to use transfer learning. And then finally outline a few transfer learning gotchas that may hold you up when you try to use this technique. So first of all, what is transfer learning? Well, the idea is that you use a model on another data set. You take an off-the-shelf model and then train it on a data set that exists. And then you get the learning to transfer, so you don't have to start from scratch. So weights and parameters from the training runs are often reused. And you'd actually take one set of data, train a model, and then use this to recognize or work on a different set of data. So the idea is you can benefit from folks' models and data sets that have come before you, so you don't have to start from scratch each time. The technique is commonly used for image recognition to train feature recognizers, but it also works well with text using a technique known as pre-trained embeddings, which are actually the most common technique used for modern natural language processing. So why would you want to do this? Well, the fundamental reason is small data sets. If your data that's available for your system is actually relatively small and you're concerned or actually already know that it's not enough to train a good network, you can actually use transfer learning to have some hope. By taking an original network trained on a very large data set and then fine-tuning it based on your data on top of the basic training, you actually can leverage the data that other folks have so that you can have a chance at training a model when you don't necessarily have enough data on your own. So the method of using this technique actually has a lot of steps. The step one is to acquire a pre-trained model. And the good news is in PyTorch, there's a thing called a model zoo that has a wide array of pre-trained models available. And in fact, you can download them pre-trained, so you can even skip the step of running the training with a larger data set and actually save a huge amount of runtime. The second thing you need to do is you need to get your data formatted into the pre-trained model's expectations. Sometimes this is going to be about size and pixel depth, but ultimately you need to make sure that your data matches the format that the pre-trained network expects. And then finally, you're going to need to adjust the output layer of the pre-trained network to suit the number of classes you're trying to train to. For example, if you get a network that's trained on 10 or 20 different classes for image recognition, but all you need is a binary classifier, you're going to be pulling off the final layers of the network and modifying it to output 2 training classes. And to give a sense of the network topology that'd be involved, you're actually going to use an input image and resize, scale, or crop it, push it through the existing convolutional layers, particularly with a network like VGG, which has a large stack of convolutional layers, and then you're going to run through a new output layer. The good news is in PyTorch, it's actually easy to load up an existing model, such as VGG, and using code, modify the network structure so that it suits your new purposes. And we're actually going to show you how to do this in subsequent videos.